Let's continue on with different exponent properties. This is product of powers and then power of powers, which is our next two exponent properties. What we want to see here is we'll talk about the y first, and then I'll fill in the blanks above. If I have x to the third is x times x times, now I'm going to write my x to the fourth. Well, that's the same thing as having 1, 2, 3, 4, 5, 6, 7, x to the 7th. So that x to the 7th, we could get that number by taking the exponent of 3 and adding it to the exponent of 4. Because exponents are repeated multiplication and I'm multiplying them, I'm just doing it 3 times and then doing it 4 times. So 3 plus 4 is 7. So if you multiply two numbers with the same base, you are going to add the exponents. Okay, so what you see here is x to the second times x to the fourth. That is going to be x to the 2 plus 4, add the exponents, which is x to the 6th. That is the same that you see over here. This is still just multiplication. So we're going to do y, 7 plus 6, which is y to the 13th. Okay, let's make these a little bit more complicated. We've already talked about what to do with the exponents when when we're multiplying. Let's talk about what to do with actual coefficients. So let's throw some coefficients in front of these z's. So let's put a 6 here, and let's put a 2 here. And now the 6 times 2 are just coefficients, and there's a multiplication sign in between them here. So we're still just going to multiply. Coefficients follow the rule of whatever you're seeing. So I'm seeing multiplication. So that 6 and the 2, I'm going to multiply those together. So 6 times 2, that's 12. Now let's talk about the z. There's two z's. One has an exponent of 8, plus the other one has an exponent of 3. So when I add those exponents together, I get z to the 11th. So we're going to multiply the coefficients. We're going to add the exponents. Okay, let's try that again. Let's add another one here. Let's go 7 in the front here. And then there isn't really room to add a number in here. So maybe if we rewrite it as 7w to the 5th times 3w to the 11th. We always want to kick it up a notch and help ourselves grow, kind of making sure we understand both how to deal with the numbers and how to deal with the exponents. So the coefficients in front are still going to be multiplied because it's multiplication. So the coefficient 7 times 3 is 21. And then for the w, I'm going to add those exponents together. 5 plus 11 is 16. Exponent property number 4 is a power to a power. So when you see parentheses, there might be in those parentheses a little number, a little exponent outside. So I'm taking x to the power of 2 to the power of 3. So it is a power of a power. There's a lot of p's there. So let's talk about what this means. This means I want to write x to the second 3 times. So x to the second, x to the second, x to the second. We just learned that when you multiply bases, you add their exponents. So I'm going to do 2 plus 2 plus 2, which is going to give me x to the 6th. x to the 6th could easily be found by taking 2 times 3. So when raising a power, which in this case was the power of 2, to another power, we are going to multiply the exponents. Okay, so right here, x to the 4th to the 6th. Okay, so we'll take x to the 4 times 6. 4 times 6 is, sorry about that, x to the 24th. Over here, y to the 2nd to the 3rd. 2 times 3 is y to the 6th. Okay? We're going to make this a little bit more complicated. Okay? Let's go ahead and give it a negative. Let's make one of these negative just to see what happens. Okay? So let's make this 7 a negative 7. So if you want to rewrite it, you can to make it a little bit nicer looking. This is what we're doing. We're doing z to the 5th to the negative 7th. What is that going to do? Okay. I'm still going to multiply those exponents. So I get z to the negative 35th. But I'm trying to bring back around some of the properties that we talked about in the previous video. When you have a negative exponent, you cannot just leave it, you can't circle it and end the problem. You have to continue and get that negative exponent positive. And the only way to do that is to bring it to the bottom of this fraction. Now you may think, this isn't a fraction. Every number is a fraction over 1. So when I take and move that down to the bottom, going to be z to the 35th is going to be on the bottom of the fraction, and I'll put a 1 as a placeholder in the top. Okay, if you'd like to see that again, let's, instead of doing this problem, maybe we go y to the negative 3rd to the 4th. It's going to end with a similar result, but let's try something a little different and make it a little bit more difficult, see what happens. This will be y to the negative 12th. When you have a negative exponent, that means I've got to move it to the bottom of my fraction. Or if it's in the bottom, I move it to the top. So it'll become positive when I move it down to the bottom with a 1 on the top. Okay? The last little piece here is not a new piece of information. It's not a new property. It just is exactly what we were doing before. Let's add some numbers in, some coefficients, and see what happens. So on the next page, page 5, just gives us the chance to talk about what happens when there's multiple numbers inside the parentheses to that power of 3. Okay? So what we're going to do with that exponent of 3, that power to a power, is we're going to distribute, here's that word distribute, which means give to each. We're going to distribute that power to each one of the factors in the parentheses. Okay? Now, just to be clear, each one of these numbers actually has an exponent. Like this 4, even though there's not an exponent written here, this is 4 to the 1st power, x to the 3rd power, y to the 1st power, and z to the 1st power. Now, all of that is to the 3rd power. So we're going to multiply. We just talked about making sure that we multiply this power on the outside times the powers that you see next to each variable. So we're going to multiply 3 times 1, 3 times 3, 3 times 1, and 3 times 1. That's going to be 4 to the 3rd power, x to the 9th power, y to the 3rd power, and z to the 3rd power. So make sure we give that to every single one. Then what we're going to do is grab our calculator, and we're going to figure out what is 4 to the 3rd power. So 4 to the 3rd power, in order to get an exponent, what we want to use is this upside down v button right here. It's called a caret. It's typically right above your operation buttons like add, subtract, multiply, divide. And right above that is our caret button. So what I'm going to do is I'm going to hit, since I'm doing 4 to the third power, we'll go 4. We'll hit that upside down V button to the, and then we'll go third power. Enter. So 4 to the third power is 64. So final answer here, I'm going to change this 4 to the third power. I did that in my calculator. Change that to 64. X to the 9th, Y to the 3rd, Z to the 3rd. How come I didn't put these together and add the exponents? Because the bases are not the same number. Okay, so those are not the same, so I'm going to go ahead and leave them separate. Okay, we'll do the last 2 examples here, giving those exponents, distributing that -2 to each one. So my 7 is going to get a -2, my x is going to get a -2, and then y, -2 times -2 is 4. So let's first deal with those negative exponents. Let's move those 2 pieces to the bottom, the coefficient and the x. We're going to move those to the bottom. So my y to the 4th is going to be the only part that remains on the top. 7 squared x squared will go to the bottom. And then we just take our calculator and we figure out what 7 squared is. You might know that off the top of your head. So 7 times 7 is 49. Or you can use a calculator. Final answer here, leave my y to the 4th. 49 for my 7 squared and x squared. Try that one more time, still giving a -2 exponent here to each one of the parts inside the parentheses. So my number 6 is going to get a -2. Then I'll multiply -6 times -2, which is x to the 12th. -7 times -2 is y to the 14th. Now there's a 0 here. So z to the 0, 0 times -2 is just 0. So your z to the 0 is just the number 1, which really doesn't do anything. Just kind of is 1 times these whole things, so it's just the same. So really, we're not worried about your z to the 0. Kind of cross that out. The x to the 12th and y to the 14th, because both of those exponents are positive, we'll leave it at the top. And your 6 squared, because it was a negative exponent, will go to the bottom. Now 6 squared is 36. So my final answer will leave the 2 variables at the top and 36 on the bottom. The last little bit of page 5 will be in the 3rd video for this standard 27.